So we're now going to talk about a new structure, number system structure, and these are called the complex. And so we're going to call the complex numbers Z. Z is a complex number that is made up of A plus BI. I make my Z with a line so it doesn't confuse you that it might have been a 2. A is a real component, B is a real component, so they look odd to you. I understand that. We'll be talking about their uses here later on. We talked about I being this 90-degree rotation, and so now I'm combining it with these real numbers. So let's just take a look at what one might look like here. This is Z, so this is a real number, 4 is a real number, and then it's attached to this I. We can graph them. So this is my real axis like we defined above. This is my imaginary axis called I. If I wanted to plot 3 plus 4I, I'm going to go out 3 and up 4. Okay, so it just said go out 3, up 4, and this location, because I've renamed this axis I, which is kind of a different thing if you'd watched the initial video. It's not really up this way, it's really coming out of my paper in a different dimension. And so you can locate it right here. So we can add complex numbers. And so hopefully just intuition would tell you, I think I can add 3 and 5 together. I can add 2I minus 6I. And there I've added them together. I can subtract them. That's just like normal subtraction. I'm going to distribute the negative. My real components, negative 3 and 2 is negative 1. I'm adding my imaginary components, and I have 1I. Take away 4I leaves me with 3I. I can also multiply. So if I multiply by I, if I recall when I was multiplying by I up here, 1 times I got me to I. And then I times another I got me I squared, which was just that reflection of 1 to a negative 1. I can do the same thing here. So if I multiply by 3I, I get 3I. If I multiply 4I by I get 4I squared. But recall from what we did up here, this I squared is the same as negative 1. So I'm going to substitute my I squared with negative 1. And now I'm going to simplify it, negative 4 plus 3I. So that should just be a 90-degree rotation because I multiplied by I. So let's check it out. I'm going to again plot the 3 and the 4I, which was this location here. The new multiplication of I is negative 4, 3. And so what it's telling me is that this should represent a 90 degree. It looks fairly close to a 90 degree without measuring it or doing anything else. Let's try it again. So I'm going to take this new multiplication of I that was a 90-degree rotation and rotate it 90 again. So I'm going to distribute. I know that I squared is negative 1. So I'm going to replace it with a negative 1. I like just the single real component in the beginning and then the imaginary component in the end. It's just really how we common notation. You don't have to do that, but 1, 2, 3. So if I go over 3 to the left and down 4, notice that this new, I'm going to change it in colors, that this new one right here is essentially two 90-degree rotations from my original because I multiplied by I twice, and notice that it is exactly a 180-degree rotation. So we use this I rotation quite a bit, like in physics. It really has to do with circuits and electricity. But oddly enough, in science, they call it a J. So we're just going to practice it in math here. We're not going to apply it to anything other than a little bit on a lecture that has to do with this thing called a fractal. I'm multiplying these just through my normal distributive property here. And I get negative 8I squared. So I like to clean it up. 4I and 6I. Notice that 4 was negative. I squared is a negative 1. So I have this negative 8 and a negative 1 being multiplied, which is going to turn into a positive. So we like to add and clean this up. 8 and 3 is 11 plus 2I. So that would be my complex number. There's something unique about a complex number that I want to show you that serves a great purpose here. Complex, being in the complex plane or system, sometimes is pretty difficult, so I want to get out of it. No, that seems weird. Well, 1 times 1 is 1, okay, and I'm just using my distributive property, and I get negative 2i. Coming back around, I get positive 2i, and minus 2 times 2 is 4i squared. Notice what happens to these two. They cancel, so I have 1 minus 4 times negative 1. Remember, I squared is negative 1. You're going to use that a lot. Two negatives make a positive. So this complex number, when I multiply, turns into a real number, so it takes me out of that complex plane. And this is called a conjugate. Conjugates are super helpful. They take us from maybe something like this binomial. Maybe I have x minus 3 and I have x plus 3. If you remember doing this, the middle terms canceled. And that actually came out kind of nice for some things we want to do in algebra. So same idea happens in the complex plane.